So when working on wireless LANs, should you focus on the what or the why? My name's Don Cook. I'm the Chief Marketing Officer at 7 Signal. With us today is Keith Parsons, CWNE number 183 with Wireless LAN Pros, Managing Director there. Heather Dremel is back with us today after 2 weeks of off and on vacation time. She is our Digital Marketing Manager here at 7 Signal. And of course, Jim Vada, our Chief Wireless Officer, is back with us as usual. So Keith, I'm going to hand you the controls. Jim's going to give you a little bit more of a formal intro, and we'll take it from there.
Sounds good, and we're always so excited to have Keith Parsons with us. If you don't know him, he's a world-renowned wireless engineer, trainer, podcaster, and he puts on the WLAN Pros conference every year in the US and sometimes around the world. So check that out at thewlpc.com. Follow Keith on Twitter at Keith R. Parsons, and check out WLAN Pros at WLANprofessionals.com. So with that, Keith, are you ready to go?
Oh yeah.
Sounds good.
Let's get going. So let's focus on what or why. And it sounds like a very simple question, and yet these answers we're going to talk about today have to do with the rest of your life, not just wireless LANs. But we're talking about wireless LANs, so let's focus on what the wireless LAN part is. Well, let's get started here and set a little timer, and let's go. Oh, sorry. So a little about me. I just achieved 100 certifications last year. One of my goals in life is to maintain the little cutting edge, and so I try to take anywhere from 3 to 5 new classes or certs every year. 100 was my goal. Yeah, I finally got there. Actually, I wanted to become a PhD at one point in time, but I had to go and earn a living for my family. So this was my secondary goal, but we got there this year. And you can follow me. It's got my Twitter handle there as well as my website. So we're here talking about something that's complex and invisible. And our families and friends, when they ask what we do, we try to, explain it. My daughter, when she was in 3rd grade, had me come to, the Show Off Your Father Day at school. And there was a doctor and a lawyer and a fireman or something in front of me. And then I stand up, and she looks at me, and she looks at her students, and she looks back at me, and she says, "He figures things out." It's hard to explain what we do to others because it is invisible, and yet it's extremely complex, incredibly complex. But the flip side of that complexity is the engineers who designed this system made it also incredibly robust. It's resilient. And the downside of both of these, one, it's obvious the downside of complexity is it's complex and it makes things really hard to understand. But the downside of resiliency, and I think this is even worse, is because it's so resilient, there is no immediate negative feedback loop. If you do something incorrectly with Wi-Fi, it still works. Now, it isn't going to work as efficiently as possible. Unless you're looking down the nitty-gritty, the end users go, yeah, it works. And then later, when something changes in the network, it stops working and you don't understand why. Well, it never worked properly. It just worked because it's resilient. So anyway, let's go on and see if there's some ways we can describe and talk about complex and invisible things. And to do so, I'm going to use Lego, of course, because we all love Lego. If you get a pile of Lego, it's unorganized, it's just a whole bunch of pieces. It's kind of like the information we have about Wi-Fi. There's lots of little pieces that we hear, we read, we hear this little one thing about, oh, if you put your AP on the wall like this, it works. And the truth is, if you put your AP on the wall like a clock, it does work. It's just not the proper way to do it, and it's not the most efficient way to use it. So when we have this jumble of information, it's hard for us to get our hands around it. So the next step we can take with that type of information is we organize it. We organize it into groups. In this case, we took the Lego, we organize it into colors. So there's little piles of different color. Now, when you're actually preparing to build Lego, this is a really great step. Some people like Adam Savage from Mythbusters calls this knolling, K-N-O-L-L-I-N-G. And it's a way to prepare to make it a little easier. but still within the color groups, we don't have as much information as we could. So not only do we need to organize the data, the information we have about how Wi-Fi works, but we need to get some structure to it. Now, some of that structure comes from groups like the CWNP, who has CWNA for the beginning stuff, SP for the security, DP for design, AP for the packet analysis. And what we've done with the Lego here is they're still organized by color, but now we've also structured that information. So not only do we see them by color, but we get sizes and shapes out of the same information. And so we need to take the information we learn about wireless LANs, and there's a lot there, very complex, and not only color code it, organize it, but structure it so that we can retrieve it a little easier. But the way I like to talk about it is you explain it with a story. The story is the part where the whole thing flows together. Now, sometimes stories aren't as accurate, scientifically, technically accurate, but they allow you to convey information. Sometimes we talk about wireless LANs and we give them people attitudes. They act like an animal, they react. We talk about something that's totally inanimate and we give it like feelings. But that's okay, because when doing that, that's how we invoke the story, and the story part is the part that you can remember. As humans, we're much better at remembering stories than we are the individual facts, even when we structure them nicely. So today, we're going to talk about what versus why. And we're going to use stories, of course. I'm done with the Lego. Now we're going to move on to the story part. So first story about what versus why. When I was younger, a lot younger, I think I was 10 or so, I spent a week one summer with my grandfather and my grandmother, and I lived with them, and I got to take a train across the country, and they picked me up, and I stayed with them in California. It was great. And my grandfather was a mechanic, and his whole life he started out as a mechanic on a little gas station, and back then the gas stations had mechanics. You took your car there to get fixed. But he worked on Caterpillars, he worked on big heavy equipment, he worked on cars, trucks, actually even airplanes. When I was visiting him, we were at a crop duster facility, but the problem he was having that day was on a Caterpillar equipment. I think it was a big front end loader. And he'd been working on it for probably 2 or 3 weeks before I got there, and was having a hard time solving some problem. So much so that the boss said, well, let's just call the factory and send a Caterpillar rep out. So I happened to be there the day, the Caterpillar rep comes out, and my grandfather's old crusty guy, at the time he probably was in his late 50s, early 60s, and this young kid fresh out of college, clean fingernails, nicely dressed, kind of a casual guy, walks in and proceeds to teach my grandfather how to fix this thing. Now, it was not a enjoyable event for me or for my grandfather, because it was kind of uncomfortable. What my grandfather was after and what he wanted from this factory rep was to be told what to do. And he actually asked that, what thing do I do? What tool do I do? Where do I go and push? He wanted the what. But this factory rep, and later at dinner that night with my grandmother, as my grandfather's explaining it, that young college whippersnapper, didn't he have dirty fingernails? He's asking me stupid questions. Well, the questions he asked were very simple. He said, why am I here? Well, to fix the thing. Tell me what to do. Why is it not working? I don't know why it's not working. And he continued to treat my grandfather like a little kid, asking why questions, and again, why, and why, and why. What he was trying to do was explain that if you don't understand why the engine does what it's doing, it makes it very hard to fix. My grandfather had years, decades of experience whacking things, turning here, feeling that, and doing, but he didn't have an understanding of why it was going on. And yet, this little college boy, within 20 minutes of asking why, had my grandfather fix it. He never took his hands out of his pockets. He never even opened his briefcase. And he walked away having solved the problem because he knew how that engine did what it did. Now, I had to listen to the complaints from my grandfather for a long time. But I walked away with that with a learning was, I don't want to be the guy with a wrench in my hand. I want to be the guy with my hands in my pockets and knowing what the other thing is. So just a quick starter there. A lot of us live our lives and we do the what's all day long. I'm suggesting we might be a little better at what we do if we can talk about the whys. So I like this picture. I stuck it in here because a lot of times in our industry, either on forums or on other online sites, people might post a picture of something they did absolutely incorrect with Wi-Fi. It is not the best way to do this. And they post a picture and they say, see, it works. Correlation does not infer causality. This little cat did not cause that to fall down. If you don't understand that, and you look at this, it's obvious the cat didn't cause that post to collapse. But sometimes when we're working with invisible things like Wi-Fi, we see something like an AP hanging on the wall like a clock and go, oh, that must have been it, sorry. And so let's not infer causality if we don't know it for sure. Well, let's go through a couple more stories. Know what your priorities are. Don't get stuck on the what. What I'd like you to start thinking about is why certain things in Wi-Fi work, how they work, what's the little processes inside. And if you completely understand those, then you can move on to the what. The reason I say hold off on the what is because what changes based on vendor. How a protocol works doesn't change at all. How an individual vendor or individual client device uses that, now that's highly dependent on their user interface. So understand how it works and why it's going on, and then we can move forward. So I'm going to tell you a couple stories about this, and these are just ones I picked off the top of my head from the last month or two, but I could go back in history and give you tons of stories about how customers, clients, students didn't understand the why and got stuck on the what. Now, the first one is about video on these farms. It happened to be a site that had a bunch of cannabis farms. Now, not all states allow cannabis to be harvested legally, but some do. And one of the requirements there is you have to have a video camera on the plants so people can't steal them, and it's just part of what you need in order to be that way. In this one area where they had a bunch of cannabis farms, there was an IT guy who said, I understand how to do video, I understand how to do Wi-Fi, I know how to do backhaul, and I'm going to offer this service to these farmers because they need it and they can pay for it. But of course, he'd like to keep the price, his cost, as low as possible. Unlike this picture, and this is just a sample so I could kind of talk to something, he had set up a point to multi-point system and had a bunch of cameras that all fed back to a central location, and the central location was connected to the internet, and then the farmers could access their video feeds from anywhere in the world on their phones. So that's the system he wanted to see. And he designed it, and it was kind of working okay, and then it stopped working, and so he's asking me, how do I fix this? First, it did not look like this picture. They weren't spread out in a fan. All of the farms were in a line down a road, and all of the cameras pointing back. Well, the cameras pointed to the fields, but the video feeds came over a Wi-Fi links back to a central location, and they were all lined up in a row. So he draws me a picture on the whiteboard and says, this is what I have. Why is it not working? You know, and his first question was, what do I type in the controller to fix this? What he wanted was the what. And I said, you can't fix it from the controller. Okay, what do I type in the individual endpoints? You can't fix it from the individual endpoints. Oh, what do I have to type in the camera settings? You can't fix it from the camera settings. And he was just getting frustrated because what he wanted was me to tell him what to do to solve this problem. And my first answer was, did it ever work? Well, yeah, it kind of worked pretty good, but then it stopped working. And of course, hopefully in your head, you just heard the same thing I did. And you've been around computers long enough to know that if it worked once and it stopped working, you did something. And I asked him, what did you do? We didn't do anything. They always answer that. And then I did a little more probing questions to come down. Well, it worked, and then we upgraded the cameras to 4K cameras. Well, obviously 4K cameras compared to HDMI cameras have a lot more data that's flowing, and that caused the problem. But the real problem was a design problem. He never designed it properly. He tried to save money, so he used one frequency, and he had 4 farms. Each farm had between 4 and 5 cameras. So there was over 20 cameras going straight back on top of each other. Now we have a whole lot of problems. A near far problem. We had a channel congestion problem. He was also using really big wide a channels, 80 megahertz wide channels, because he thought that's going to go faster. He made a bunch of critical errors in the design phase that couldn't be compensated with by just typing some commands into the system. I said, well, why don't you have individual point-to-points? Well, it costs too much money. Well, I know, but you have 20 cameras running 4K over a single video channel. And he was like, so? He didn't even understand the capacity issue. So when you're looking at problems, don't lead to the what, figure out why. Once we figured out why it wasn't working, the solutions dropped right out. Now, he didn't like any of the solutions because they cost him more money, but it was also the only way to fix the problem that they're having. Of course, you could have put wires in, but this was over miles. Next, what versus what? Many of you have CWAP credentials. The one that I like the most is the CWAP. I think it's the one that teaches you the why. I recommend if you're going to be in this world, you start with the CWNA and you move to CWAP next, because it's the one that if you understand it, everything else falls in place because you're understanding how everything's working. Versus going to a Cisco or an Aruba or a Mist or a Juno, anybody, any other vendor. The vendor classes and the vendor courses and the vendor exams are to teach you how to do something using the what of their specific interface. The why is it doing that way? Now, these are both complementary. On Twitter a couple days ago, people were saying, should I get a CCAE or CWNE? I'm like, both. One's to learn how to do it really fast and efficiently on Cisco. That information isn't terribly transportable over to Aruba, but the CWNE is transportable between all vendors, but it's a different way of doing things. It's more of the why than the what. Another little story happened a couple months ago. WISP is a wireless internet provider, came to me saying, we can get money from the US government, part of COVID, part of trying to do rural ISPs, like 100 years ago, we had the Rural Electrical Board that tried to bring electricity to all farms in the country. They're trying to bring ISPs in. Now, it's been lobbied really heavily by the fiber companies, and so they put as the limit, you need 100 meg download to qualify for broadband. And so this WISP came to me saying, how can we deliver 100 meg to each of our customers? And I just rolled my eyes and went, you can't. It's not going to be cost effective because there's only so many frequencies available. And of those frequencies available, if you use up one to one customer at 100 meg and you guarantee that delivery, you're not going to have a whole lot of other customers that can share that. And the sharing is the ratio. And I said, you might get close sometimes if you only test one at a time. But in aggregate, if you have 10 on one segment of your WISP and you all try to get 100 meg at a time, the frequency just can't do it. Now, they had already put in grants to the government. They had already built towers. They already had customers, and they were trying to solve a problem after spending all this money to say, why are we not getting 100 meg? We need it in order to get reimbursed. It's a little too late when you're at that position when it can't be done. Why? Because the capacity of the radio waves can't support the thing they were trying to do. Part of this was also because they were believing all the marketing literature that said, oh, our thing can do 7 gig or 20 or whatever the marketing is. That's not actually true because it's only the payload that counts, not the data traffic. Anyway, understanding the why would help. So when we get to Wi-Fi, what do we need to do to get the learning of the why of the Wi-Fi? So the rest of this, we did some stories to get here. Now the rest of this, I'm going to slam pretty fast. I'm not going to get into a lot of detail, but I wanted you to have the slide deck that you can download after this is over with the information as kind of a roadmap of the things you need to know and understand intrinsically, so that when you go out to solve Wi-Fi issues, you know the why. You can go to the vendor to find out the what, but to know the why, let's get started. So first, RF fundamentals. You need to understand how RF works. It's not magic. It is invisible, so it's kind of hard to capture, but you can learn this. There's a boatload of protocols. Now, obviously, this is too small to have, get up really close and read, but there's so many protocols that we have to deal with in wireless. It's not just 802.11. 802.11, yes, is big, and it's got really cheap chipsets, and it's everywhere. But there's a bunch of other protocols we need to learn. So understand how the RF works for the protocol you're after. There's a wide spectrum out there. There's lots and lots of RF available to us. Now, there's only a subset of these spectrums that the FCC allows us to use in Wi-Fi, and we'll talk about those. 2.4 gig frequencies, those are available. They're unlicensed, both Bluetooth, BLE, 802.15.4, and 802.11 all share in this space. So here's a chart that shows all of that with a lot of extra information. I'm not saying you need to memorize this, but you need to memorize this. It needs to feel very second nature to you of the differences and how they each use this, how wide the channels are, where they are, what the wavelengths are, what the path loss is as you're using this. So a lot of information on 2.4. 3.5 is a new, well, for the US, it's fairly new. It's been around for a long time, but now we're allowing CBRS into it. And we have a secondary, we're not the primary user, but there's a lot of things going on in private LTE in this space. Hopefully you're learning, you're getting up to speed on CBRS. It's going to be in your future. Now, 5 gig, we've been using 5 gig for a long time. Again, there's some channels in the Uni 2B we totally lost. I left them on here so you can see where the contiguous space is and why those are missing. But yes, you need to understand how this works, both for your own country and for the other countries you might be needing to support, because they are slightly different. 6 gig is on the way, it's coming. We have a lot to learn there. Lots and lots of space, how it gets allocated, how people individually use it. Yeah, it's one of those whys. Why in 6 gig do we not have the same problem that we have in 5 gig, that if I go to double the channel, I have higher noise floor? We fixed that in a way in 6 gig. Another thing you need to learn how to do. So I'm just zooming in here so you can see the details. For each of these, you can see the wavelength, you can see the bands, their numbers, and there's even formulas that tell you how to calculate up the channel number for each of these. And the free space loss at 1 meter, so you can compare the free space loss between them. Yeah, I don't know how to say this anymore. You need to know dB math. You need to be able to do dB math in your head just as fast as you can convert. I was going to say convert metric to imperial, but many of us can't do that. But as fast as you can, count your fingers. You need this, needs to feel comfortable. That it's not a stop and oh no, what did they mean by that dB? You just need to, you need to be bilingual. dB math, normal math, you need to understand them both side by side. Free space path loss is another subset of the RF fundamentals. You need to understand that how this changes, and it changes a lot of things we're going to be doing from, oh, I need to go twice as far. Well, how much more energy do I need? I need to not be, why can't I be close to an AP? Well, because when you're really close, they're super, super sensitive to things. And what's the difference between 2.4 and 5 gig at any one location? And it's not because 5 gig radio waves have a hard time. It's because the receive aperture on the 5 gig is smaller, and thus it receives 6 dB less information. So I've seen even professionals sometimes mess up on this little one. So you understand RF, but you also need to understand the RF modulation process, because everything we do to carry data is tied to this process. Now I'm going to rip through these really fast. We have a sine wave. When you rotate it, it looks like this. When you rotate it again, it can now show a constellation diagram. BPSK, it's the first of the MCS ones, very simple. And we have a very simple and yet incredibly robust method of being able to show something called error vector magnitude. It is where our mistakes can fit. And at BPSK, we have the ability to have a lot of mistakes and still pull off an actual true 1 versus 0. It's very simple. But if we want to send faster data than 1 bit per cycle, we go to QPSK. We have a smaller, it's literally half as much robustness. Our robustness got cut in half, but we now get to send twice as much data. It works the same type of way. If you really want to get into the modulation, I've got a video and you can watch how that works. It still allows us to have errors, but not as many errors as the BPSK. And then we go faster to 16 QAM, and it goes even faster. And this is not our target that we wanted in the initial question, but what the target we really wanted was to get to 64 QAM. And this is where it's kind of the sweet spot for the amount of data that we want to carry. It's still robust, kind of, but we're getting 6 bits per cycle. And that's enough to push some pretty decent data rates. It's still not the fastest. When we get up to 256 QAM, we're going to have this huge amount of possible choices, but we're not robust at all. It still requires a whole lot of SNR, at least 30 dB, sometimes higher, which is why if you try to design this in as your design requirement, you'll probably fail, because you'll have to have your APs so close to each other that you're then going to have co-channel interference to offset it. So all of that comes down to when you're covering RSSI and when you're covering SNR and noise and modulation, you need to understand how that affects everything. So that's RF, modulation, know your antennas, know how to read these pictures, because some people get confused with this picture and they think it's talking about how far it goes. If you think of the antenna as a balloon, the transmit power is the air in a balloon. The shape of the balloon doesn't change, it just gets bigger and smaller. This is more like the shape of an antenna's balloon, not necessarily how far it goes. And so we have to have more information. This is just trying to show us the shape. Now, when you get to antennas, if you care, I have a paper visualization tool you can print and try out. So that you can, this one's made for 30 degrees, but you can make one for 45 or 60, whatever your antenna is, that allows you to go on site and visually see how far, where your coverage patterns are. Antennas are not created equally. Here are 2 APs in the same price point, within, I think they're within 5% of each other. And one has a negative, it went from a 10 dB input to a 967 output. And the other goes from a 10 dB input to a higher than 18 output. And they both price the same. There is a difference in antennas. And when you're changing your designs, you have to know your antenna before you do the design. You just can't swap them. And this is just a reason why. You need to know the PHY, how the PHY works, how the contention process works, how each individual transmitter needs to wait and get in and have its time to play the game. My favorite charts ever, MCS charts, I love these because they're self-reporting. Any MCS index you receive is the transmitter saying, I tried and I failed and I got to here. So if you don't understand how this works and why a client would act a certain way versus a different way, and why they were someplace and they're now a different place, it's a wonderful tool to understand the why of Wi-Fi. Now, a lot of people, I like running this demo. If I had time, I'd run this live demo. But this is a screen capture from a Wi-Fi bridge I had set up. And you can see, obviously, one has 2 dB differential, and yet it's running an entirely different QAM. Its modulation scheme is different than the other modulation scheme, and that's normal. They don't have to match. I've seen a QPSK and a 64 QAM 2 ways. And if you understand the why behind that, another why you need to be looking at. It's not about the green. Here are 2 APs that we measured in a football field. And the one that outproduced is the one on the right, which had less green, but it produced more. And the reason was it had higher spatial streams. And if you don't understand why a spatial stream would have you increase throughput, go back and learn. Same with Wi-Fi 6. This was our data we collected that shows even an old ThinkPad that had a Wi-Fi 6 chipset in it outperformed anything that even had a 3-stream Wi-Fi 5 chipset in it. Now you can do this data on your own. It's not that hard to pull off. And a big one here is we get, and there's an entire, I did an entire session with 7Signal on this, why the PHY overhead matters. We get this idea that we think, oh, I need to go to 80 megahertz wide channel versus a 40 megahertz wide channel. Yeah, that's possible, but realize how much overhead is there. The bottom two on this scenario are showing that the only thing that's different between the two is the blue, and the blue happens to be the payload. Again, blue is the only payload we have. Need to know your MAC, how the association process works, how clients join, what happens when you get to captive portal, how all of that works. You need to know the upper layers of the network, because even though we're on Wi-Fi, the data is going to be traversed the wired network. And of course, everyone blames the wireless network whenever the wired networks fail. There's a whole series of network surfaces you need to understand. I hope you're getting a little overwhelmed in the amount of things you need to know for the why. Sometimes we get stuck in the what of how we do something, but you need to understand this whole big picture. And for each one of these little circles, you need to understand why they work, how they work. And then you can apply that to the what of how you actually go about fixing it. So a couple more slides just for fun. And last recommendations. What do you do next? I think you should engage with the wireless community. There's hundreds, if not thousands of people involved in Twitter and Slack on webinars like this that can help you in your learning process. Try to truly understand how Wi-Fi works. Really understand, not just a cursory knowledge. If you don't have a home lab, get a home lab. Just about every CWE I've ever interviewed, one of the things that is consistent across all of us is they all have a home lab. Never stop learning. I'm an old guy and I took 5 classes and got certifications last year. You don't have to be a no tricks kind of guy. New tricks happen all the time. There's lots of places you can get free training or paid training, but stay on top of it. So final recommendation, work on the why, not on the what. Thanks.
All right, Keith, thanks so much. And I want to invite anybody out there that has a question for Keith, drop it in the Q&A. We'll have a few minutes to tackle those. First question from Divakar. Apologies if I got that wrong. But they're asking Keith, I think you'll have a good answer for this one. What's a good signal strength for designs?
Oh yeah, I'm gonna quote our friend Samuel Clements on this one. It depends. For me, it's what are the requirements? Mm-hmm. So there are different requirements depending on what you're designing for. I did some work for General Motors once, and they had made in their corporate headquarters, and they had made some pretty substantial mistakes in one of their designs. And I said, if you were working inside GM and someone came to you as a product designer and said, I want you to design me a vehicle, they're going to go, well, what do you want it to do? Oh, I want to go 0 to 60 in 6 seconds. Well, you might get a Corvette. And then they say, but we need 7 cup holders. Well, you might get a minivan. But I need to carry 2,000 pounds. Well, you need a truck. And to say, what kind of vehicle do I need? Well, that's too broad a question. So the question was, what RSSI do you do? Well, what are you trying to do? If you're trying to go to barcode scanners that are 10 years old and they can work easily at neg 80, then design for neg 80. That also means you're not going to get voice over IP. Your iPhone probably won't work, but the thing you designed for can work. So it's all about requirements. It's what is the requirement and design to meet those requirements.
Yeah,
and I'm sure you knew I was going to say that.
Yep, it's absolutely one of those that you have to know the why before you can get into the what. Why are you designing? What purpose is it going to serve? What are the requirements? What's the network supposed to do? And then you can start answering that. So A question from Chris. I don't know if you know anything here, Keith, but just he wants to know if there's any news on the WLAN Pi version 3.
Stay tuned.
Okay.
And yeah, there's a lot of people right now working on the project, trying to come up with a new WLAN Pi, because the old ones, we couldn't get the hardware. So there's both software teams working and hardware teams working. We should see something fairly new, fairly soon.
A lot of their work is, you can
Sorry.
see what they're doing on GitHub, at least on the software side, if you want to go search for that.
Yeah.
So, Rodrigo has a question. He says, why can't we see the MCS index on Windows?
Because the driver manufacturers who made it didn't code it in there. The chipset has to do it. It's actually doing it. It's just not reporting it back up to the stack. So there are some drivers for some specific chipsets that have the ability to do that. But if you're running just generic Windows drivers, for whatever reason, Windows just decided not to send that up the stack. So it's obviously there. It's being calculated. It's being used. You can see it remotely. If you do a packet capture, you can always, it's carried right on top of in the header. It's not like you miss it. It's just the Windows client doesn't reveal it to the user in the interface.
Yeah, and I have to add, we've taken what you can get from Windows, the data rate, the channel width, and so on, spatial streams. And so we've reverse engineered the MCS index for Windows clients in Mobileye. So check that out at 7signal.com.
Good point. Yeah, the information's kind of there. There's a couple numbers where you get the data rate and it could be this or that, and then you have to say what spatial stream am I on and how wide is the channel, and then you can get almost perfect answers. But you just need, there's an algorithm behind it, and you've done it.